I am sure you've all seen a periodic table of the elements. There's probably one up in your chemistry classroom right now. Over the course of this course, we will come back to the periodic table again and again and understand its intricacies at a deeper and deeper level. But the periodic table is an amazing organizational structure for the 120 or so known elements. And what I hope to do in this lesson is give you just an overview of what sort of information can be gleaned off of the periodic table. But first, I want to show you a few periodic tables before we get into the nitty-gritty of it. So if you're on campus here at Goucher, we have a wonderful periodic table in the chemistry hallway. It's actually located outside of room 226, and I would encourage all of you to go up there and spend some time looking at it. So we got it in January of 2017, and it contains samples for each of the elements, both of, well, for many of them, of the pure elements, but also of compounds that contain that element. And you will find some very interesting surprises as to what objects of everyday life contain certain elements. So definitely spend some time with this periodic table. I know the chemistry professors here still walk by it every day, but stop and look at it on the way to our labs. So if you were to Google periodic table, you might come up with the following table. This is from aptly named periodictable.com, and this has a picture of the pure elements. And then you can see from these pictures that many of the elements are metals, and we will get back to that shortly. This is another periodic table that you may not have seen, and this is actually the first periodic table that was published. So the chemist who takes credit for developing the periodic table, or at least the earliest version of it, was a Russian chemist named Dmitry Mendeleev, who lived from 1834 to 1907. And he published the first periodic table in 1869. And what he did is he listed the elements in rows in order of increasing atomic weight. And what he would do is start a new row when the characteristics of the elements began to repeat. Okay, so if you look at the top row, well, first there's hydrogen on the top, and we'll get to hydrogen later in this course as to what has to happen to it. But you can see lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. And next to each of those elements is their atomic weights. And then below lithium, we see sodium. And below sodium, we see potassium. And then eventually, we see rubidium and cesium. So those have the same vertical relationship, of course, as the modern periodic table. And then some of the other elements are thrown in there. So titanium is in group 4 under silicon. Well, that's not the way it is in the current periodic table, but we will examine what some of the relationships are between things that were originally combined in the same columns on Mendeleev's table. Okay, and there's a picture of Mendeleev over there on the right. Okay, so for the modern periodic table, a couple of the terms that you need to know. First of all, periods are the horizontal rows. Okay, so numbered 1 through 7. And then groups are the vertical columns that are most commonly numbered 1 through 18, left to right across the periodic table. But in this table, as in many, you can see that the groups are also numbered with Roman numerals A's and B's. And we're sometimes going to find this numbering system to be more useful. Okay, going back to the example that I talked about on the previous slide, silicon is in group 4A using the Roman numeral scheme, and titanium is in group 4B using the Roman numeral scheme. So you can see that there are some intrinsic relationships between these two elements. Okay, so then many regions of the periodic table have names that you should kind of know. So the elements in pink are the ones that are the true nonmetals, so hydrogen, carbon, nitrogen, oxygen, phosphorus, sulfur, selenium. There are other nonmetals, but they have more specific names. So specifically, the column 17, group 17, is also called the halogens, and group 18 is also called the noble gases. Then on the left side of the periodic table, you have a lot of the metals. So group 1, with the exception of hydrogen, hydrogen doesn't really have a good place. But the rest of the elements in group 1 are called the alkali metals in orange. The elements in group 2 in red are called the alkaline earth metals. Then the elements in the center of the periodic table in groups 3 through 12 are called the transition metals. They are in purple on this table. There are some other metals that are called main group metals. So the groups that have letters 3A, 4A, 5A, 6A, 7A, 8A, those are all considered main groups as opposed to transition elements. So there are main group metals that are in green. Then in blue are what are called the metalloids. We'll get to that a little bit on the next slide. And then finally, two other areas of the periodic table are these extra boxes near the bottom. So you have in yellow the lanthanides. Those are 14 elements starting with lanthanum. And then in green are the actinides, which are also 14 elements starting with actinium. And where these fit into the periodic table is the yellow block and the green block in the lower portion of group 3. So as I said, you probably want to know what the different groups, at least the alkaline metals, the alkaline earth metals, the halogens, and the noble gases are. Okay, so back to the topic of metals versus nonmetals. Okay, so this particular table makes it clear that everything in blue is a metal, everything in yellow is a nonmetal, and then everything in green is a metalloid. So metals, the properties of metals is that they conduct electricity, and they are both malleable and ductile. What does that mean? Malleable means that you can kind of bend them without them breaking, and ductile means that they can be pulled into wires. And the fact that wires can be made out of metals is very, very useful in terms of modern technology. And then on the bottom left here are several metals. So copper, of course, has a very distinctive color. The rest of the metals you might not be able to tell apart just from looking at them, but some other common metals are titanium, nickel, aluminum, iron, and zinc. Okay, nonmetals are insulators, which means that they do not conduct electricity. Some of them we'll see in the next lesson are solid, some of them are liquid, some of them are gases. Depicted here in the picture are solid nonmetals. Okay, so we have arsenic, iodine, selenium, sulfur, carbon, boron, and phosphorus, red phosphorus specifically, in this picture. And they are all mostly powders of some sort. Okay, so they're not malleable and they're not ductile either. And then metalloids, again, the elements in green, physically appear to look like metals, but they actually, in terms of their properties, behave like nonmetals. Okay, and then there's one more important reason why we care about metals and nonmetals. Okay, so I've already talked about in the first lesson that compounds are simply elements that are bonded together in some sort. And we talked about how molecules are atoms that are linked together using chemical bonds. We're going to talk a lot more about chemical bonds later in the course, but just to get your appetite whet on this, there are two types of chemical bonds. There are ionic bonds and there are covalent bonds. And the general rule of thumb is an ionic bond is what you get when you're combining a metal and a nonmetal, and a covalent bond is what you get when you combine two nonmetals. There is also metallic bonding, which is the bonding within a solid chunk of metal, whether it's a pure metal or a mixture of